Hey there, Mr. Weaver here, and this is topic 2 and 3, lesson 3 on function notation. After this lesson, you need to be able to write functions in function notation. You need to be able to evaluate functions that are given in function notation, and you need to be able to explain the meaning of the parts of function notation in context. After this lesson, you'll know you're successful if you can write a function using function notation, evaluate the function given in function notation, and describe the meaning in context of our function notation. So first, let's focus on writing functions in function notation. Reviewing what we did before, we have our domain as our inputs and our range as our outputs. Function notation is just a different way of writing variables as one is a function of other. Generally, you're going to see that y is a function of x, where x is our input, y is our output. Function notation is written like this. So instead of saying y equals, we say f parentheses x equals. And this is pronounced f of x. We don't have to use f and x. We could use other variables. So we could say g of t, whatever variable this might be. Something's a function of time where we could use t. And then we'll get to this a little bit later too, but when we are evaluating functions, there are 3 steps. So first, you're going to substitute the value that's in parentheses for every instance of x, or your variable. 2, you're going to use order of operations to simplify, so following PEMDAS. And 3, interpret the solution. And we'll talk about what that means in context in a little bit. So writing something in function notation is simple. Instead of saying y equals 5x, you just replace the y with f of x equals 5x. The next thing that we need to learn about for function notation is evaluating functions that are written as function notation. So when we're evaluating functions, if you think back to the first activity that we did with a function machine, if f of x equals 3x plus 5, and I want to know what is f of 4, well, I'm going to take my end of my expression here, and that is my rule. So here I would have to multiply by 3 and then add 5. My input is my x value. If you notice, x is the number inside of parentheses. So in this case, it is 4. So I'm going to take the number in parentheses, 4, and plug it in to my machine in place of x. So I would plug in the 4. Now I have 3 times 4 plus 5, and I would get out 17. So in this instance, I would say f of 4 equals 17 because I plugged in 4 and I got out 17. Another way you can think about function notation is you are just substituting what is in the parentheses, again, in for every place of the variable. So if I had 6x minus 4 and I want to know f of heart, instead of that x, I just put in the heart because that's what was in parentheses. If I wanted to know g of moon for negative 2x plus 9, I would do the exact same thing as before. Instead of the x, I'm going to plug in what's in parentheses. So in this case, it's the moon. It follows that same type of pattern no matter what expression we have to plug into. So if I wanted to do t of star, I'm going to plug in a star where that x was. If I have more than one place where my variable shows up, so this time I want to know r of smiley face for 12x minus 10 plus 2x, I can plug in that smiley face for every instance of my variable. So in this case, it would show up twice. I could have also combined like terms at the beginning and done it that way, but in this case, I chose to substitute my smiley face in for both instances of x. I don't have to just replace symbols or numbers. I can also do other variables. So if I had m of a for x plus 7, the same thing would apply. I can plug in that a in where x was, and I would end up with a plus 7. It's still just substituting. Okay, so through all this, if we are given a number, I just take that number that's inside parentheses, plug it in where the x was, and then because I have a number, I can multiply it out. And we'll see that next. Some calculator tips for you. So here are some tips for if you have a handheld graphing calculator. But most people are going to be using Desmos. So in Desmos, we covered this in previous lessons, but you're going to type in your function. So let's say this time I want to know f of x equals 3x plus 2. Then click that little gear symbol and turn it to a table by clicking in the table. When we're doing this, it will give you all your x values and your y values. And if you want more rows at the bottom, click on the last x value and keep hitting enter till you get what you want. Or just type in the x value you want and it will replace it with the y value that you need. And regardless of which type of calculator we use, x is still our domain and y, or f of x now, is our range. So let's put this into practice and practice evaluating a couple of different functions. So we have g of x equals 5x plus 1 when x equals 3. That just means we're going to plug in 3 for x. So 5 times 3 plus 1, 15 plus 1 is 16. So g of 3 would be 16. Or g of x is 16 when x equals 3. One other example, if f of x is equal to 3x minus 6, and I want to know f of 1, again, that just means take the number in parentheses and plug it in for x. So 3 times 1 minus 6, or 3 minus 6, is negative 3, which means f of 1 equals negative 3. Now it's your turn. Pause the video and try the 2 problems on the student does side. We'll check our answers at the very end. Our third goal, we need to be able to explain the meaning of the parts of function notation in context. So here are some contextual situations. Rachel makes money by selling bracelets for $7 each after initially buying all the supplies for $10. As represented by the function f of x equals 7x minus 10. Evaluate and explain the meaning of f of 4. So we have our function, f of x equals 7x minus 10. The 7 is how much each bracelet costs, and then minus 10 because she originally lost money for buying supplies. What is the meaning behind f of 4? Well, if we plug in 4, so 7 and then the 4 where the x was, we end up with 28 minus 10. So f of 4 equals 18. In this context, that would mean our input was 4 and our output was 18. So this would be like her selling 4 bracelets, then she makes $18 in profit. X in this situation is how many bracelets, and then our y value, or our f of x, is how much money she has. In the situation above, what does f of x equal 200 represent? We are already told that the answer is 200. So y, or our output, equals 200. If we think about what the equals part was above, that was $18. So now it's 200. So that must mean she made $200. Okay, 200 is our answer, which is her profit. So equals 200 would mean she made $200 by selling X bracelets. We don't know how many bracelets, but we could figure it out. It's your turn again. Pause the video and try the next two problems on the student does side. Again, we'll check our answers at the very end. One final thing that we can do with function notation is start to translate our statements into coordinate points. In the future, we're going to need to be able to graph these functions, so being able to turn them into coordinate points is extremely helpful. If we think about what we need for a coordinate, we need an x value and a y value. Both of these are hidden within our function notation. So our x value, again, was the number inside parentheses, which is why we can take that number and put it in place of x, because it is x. So x is -1. To get our y coordinate, we need to think about what the y represents. That represents our output, and in this situation, f of x equals 1. That's showing our output. And since f of x is the same as y, that means y is 1. Our output is 1. So to make a coordinate, we're just going to take those two values, -1 and 1, and write them as a coordinate. And that's really all there is to it. The number in parentheses and the number equals, those two numbers together make your coordinate. Pause the video and try the last problem on the student does side to make your coordinate point. We'll check our answers in the next slide. Here are all the answers for the student does problems. So pause the video here and check through your answers. In this lesson, we were introduced to function notation, which is just another method of writing y as a function of x, or for whatever variables you're given. It's written as f parentheses x and pronounced f of x. When we're evaluating a function, you just take the number inside of parentheses and substitute it for every instance of the variable in the expression. Follow your order of operations to simplify and determine the solution if there is one. When we're talking about context, x is your input value, or your independent variable in the situation, while f of x, or y, is your output, which also represents your dependent variable. Using those two things together, we can turn our function notation into a coordinate point where x is your first coordinate number and f of x is your second coordinate number. After this lesson, do you now know how to write a function in function notation? Can you evaluate a function written in function notation? And can you explain the parts of function notation for the context of your problem? If you're not sure about those things, go back and watch pieces of the video to help deepen your understanding of the concept. And that's the end of lesson 3 on function notation.